My name's Nick Randolph, and I've been doing Windows platform stuff for about as long as Microsoft. So dating back to Windows Mobile, Windows Phone, Windows, and now obviously the Universal Platform. So hopefully out of this session, you'll get a good understanding of what's new in the platform, but more importantly, what it takes to actually build for the platform. This is a 200 session. I've got a 400 session tomorrow. If you want the hardcore stuff, go to that one. So we're going to jump straight into it and do a little bit of an overview of the platform. And as I said, I've been around a while, and the Universal Windows Platform is the next evolution of developing for Windows. Okay, so how many people here are built for Windows Mobile? Okay, a few, and I mean Windows Mobile, not Windows Phone, Windows Mobile. Okay, so a couple of you. Okay, back in those days, we were kind of building in what was a version of Windows Forms. You know, still C#. We still have Visual Studio. And surprise, surprise, we're back building that stuff again today, okay? We're back into a world where we've got multiple windows, okay? We're back in a world where, you know, we can do a lot of the stuff that we used to be able to do. We are still working in a sandbox, so back in the days of Windows Mobile, we were actually, you know, we had pretty much open slather on the device, which was a double-edged sword. I mean, we could do pretty much whatever we wanted to, but on the same token, a lot of people did exactly what they wanted to. And what we ended up with is a really average user experience. And actually, wasn't helped by the fact the OEMs decided to put their own sort of rubbishware on the devices. So we ended up with users complaining that the devices were not responsive. And actually, if you strip back everything that was on there, you could actually build a very responsive application. Okay. If you look at the evolution from back in the Windows Mobile days, Microsoft's gone through a couple of iterations to get to where we are today. So the first of those was Windows Phone. So back in 2010, when they kind of went forward with Windows Phone, we had a very sandboxed environment. And that was the first incarnation of this sort of sandboxed environment. Now, actually, the platform that we're building on, which is XAML and C#, or XAML and pick your language of choice, or even C++, actually dates back to the Silverlight and the WPF days. And those technologies, whilst they're still around today, play second fiddle to where we're going with the Universal Windows Platform. Now, don't get me wrong, there are still things that you can do in WPF that you can't do in the Universal Platform, but those two roads are going to converge eventually. If you look at the evolution of those platforms, or of the Windows Phone platform, we saw it kind of leapfrog with where Windows development went, or Windows desktop development. So from Windows Phone days, we then had Windows 8 development. And there were things that got introduced as part of Windows development, or Windows 8 development, such as WinRT, that weren't there in the Windows Phone, sort of, which came out of the Silverlight world. Okay, so we had this sort of weird model in the phone space for a while, where we could build in Silverlight, or we could build using WinRT. And so with Phone 8 and 8.1, we kind of leapfrogged with Windows desktop development, because then there was Windows 8.1, and that had some of the things that the phone introduced, but then it had some new stuff that the phone didn't have. Okay. The good news is we have one platform now. So I'm no longer a Windows Phone MVP, I'm now a Windows MVP. So I build for the Windows platform. Okay. And so when you're talking about developing, or you're going to talk about a project that you're going forward with, depending on whether you're targeting new devices or whether you have to support legacy ones, if you're targeting new devices only, you can say that you're building one application, okay? You can build one application and you can deploy it across phone, tablet, desktop, Surface Hub, HoloLens, Xbox. Okay, that's pretty cool, okay? Now, okay, that's the marketing speech over and done with. There are some negatives to that, okay? So imagine that you're building different user experiences for every single one of those platforms, and you package them into a single application. Okay, all of a sudden things are going to grow in size and may not perform the way that you want to do. Okay, so tomorrow in my talk, I'll actually talk about the negative impacts of having all of your user experience packaged into one file, and some of the scenarios that we've run into and how we've addressed them in terms of actually optimizing our application. But the important thing is that we've got one API. Okay, so we're building against one set of APIs. You can still pick your language of choice, okay? So if it's C#, VB, and you design a language in XAML, you can get away with not using XAML if you really don't like it, but I would strongly encourage you to get familiar with it and start to use the tools, okay? Mainly because the design tools that you get, both in Visual Studio and Blend, actually make it really easy to build applications. Microsoft's investing very heavily in those tools, okay? With Visual Studio 2015, we saw them take things from a ground level up. Now, from a user experience perspective, you probably didn't notice a huge amount, but underneath, they changed the compiler, they changed the compiler technology, they changed all the design surfaces. So now, what you're seeing across Visual Studio and Blend is actually the same shell there, okay? So Blend used to be completely separate from Visual Studio, now they're converged into effectively one product, or one shell. Now, unfortunately for us Blend developers, or people who are familiar with Blend, there are certain things that got left off the table. So, for example, you used to be able to import certain graphical assets, for example, Photoshop files and Illustrator files, and they would come in as XAML resources. That feature actually got removed because it fell below the cutting board in terms of where things they could get to in this shipment cycle. They are well aware that those things are missing and they need to add them back in, okay? There are a couple of shortcut keys that Blend developers like to use, like fit to screen, and the one that I used to like was basically hovering a mouse over a particular value in the properties window and actually just dragging it to adjust heights and widths. That's gone, okay? It's not that they don't recognize the value of those, it's just because they're trying to get them onto a common shell. There were certain things that didn't make this shipment cycle. Okay, let's come back to look at what other technology we can build with. We can actually build using C++, okay? Again, you can either use that DirectX or you can use XAML packaged with your C++. And of course, you can build using JavaScript. And actually, one of the things I'll talk about tomorrow is actually the different types of things that you can do with HTML and JavaScript within your application. In fact, you can actually ship an application on the Universal Windows platform with 0 lines of code that points to a mobile-enabled website, okay? So you basically point at a URL, you say, hey, this is my website that I want to render within my app. You package it and deploy it into the store. That's pretty cool. Where that gets even more interesting is what you can do to actually access certain device-based features. So you can access Cortana with that. Okay, you can actually detect that you're running on the Windows platform. You can integrate with Cortana, and you get it to launch. You can actually get it to execute background tasks and things like that. So that's pretty cool. Going beyond the actual platform itself, if you look at the broad range of updates that Microsoft are shipping, it's not just, okay, a change to the APIs. It's the fact that we're building one application, which means one store, okay? We're not shipping, a phone app to the phone store and a desktop app to the desktop store. We're actually building one application. We're deploying it to one store. Microsoft obviously recognized that people have already invested heavily in phone and desktop development. So they do provide the ability for you to ship 2 packages. So you can upgrade the phone to Windows Universal, you can update the desktop to Windows Universal, and you can go forward and actually have those both submitted to the same store. So there are some smarts in the store that do allow you to obviously support existing older technology, so the old versions of the phone and desktop platforms, but also ship multiple packages if you want to. Now, that's obviously not the preferred mechanism. They prefer you to ship one package. There's one set of SDKs and tooling, okay? So we don't need to download different SDKs and different bits and pieces. And if you actually look at the way that the tooling's evolved, it's out of bound outside of Visual Studio. So Visual Studio's got quite a slow shipment cycle, although even that's increased in frequency. But the important thing is that the tools for universal platform development are also out of bound, okay? Which means that they can actually ship multiple versions of them. And in fact, if you're looking at the Insiders program, the Insiders program's been iterating the desktop builds quite frequently, and there's actually a preview version of the SDK that you can, again, download and install. And there's actually mobile emulators that go with that as well, so you can download and install those. And you'll see that featured up in the product. There's a version number that often gets appended to things, and those are the versions of the SDK and the tooling that you need in order to target them. Now, when you're looking at deploying an application, obviously the versioning is quite important, because if you select the most recent version to target, because there might be some unique feature that you want to take advantage of, the downside of that is that, of course, older machines, so machines that might have, say, the RTM version of Windows just installed and they haven't applied the updates, won't be able to see and install your application, okay? Now, what will probably happen, is I haven't tested this in the store because they haven't gone through this yet, is that they'll be able to see your application in the store, but they probably won't be able to download and install it until they've applied the updates. Okay, so one store, one dev center, and moving forward, everything's going to converge. I mentioned before there's a couple of different choices in terms of what you're going to be building with. Okay, so UWP is the preferred platform. So this is basically building natively for the platform. But if you've come from applications on other platforms, so you've got an iOS or an Android or even a mobile website, there are a number of bridges that Microsoft are talking about that are going to come to the platform to enable you to migrate your application to the platform. Those are still under development. The Silverlight one is more of a migration tool, so it's basically taking your Windows Phone application, running it through a migration to get you to the point where you're building a universal application. And the web one is more of a packaging technology, so that you can take your existing mobile site or your existing Win.js site application and migrate it to the Windows platform. The last two are a reference to cross-platform technologies, okay? If you haven't heard of Xamarin, if you're looking at doing multiple platforms, I would highly recommend taking a closer look at them. The stuff that they're working on and the frequency that they push out new builds is unbelievable. So the nice thing about Xamarin is if you're building for the Windows platform up front, so long as you architect your application correctly and you separate the visual side of things, so the page layouts and the page designs, away from your core business logic. And all of your business logic, your services, your data tier, all of that resides in a portable class library. What Xamarin will enable you to do is take that portable class library and effectively target it for iOS and Android without changes. All you need to do for those other platforms is build the user experience layer on top of it, okay? And in the case of sort of traditional Xamarin development, you use storyboards and Zibs for iOS, and then you're going to use AXML for doing the design for Android. Now Xamarin Forms, which they're now up to sort of version 2 of, and it's becoming quite mature, is a technology where you can essentially build the layout of your application once and have it build a version for iOS, Android, and currently they're supporting Windows Phone and Windows Desktop, and the UWP version is currently in preview. This is quite interesting, particularly if you're looking at the cost of deploying or cost of developing internal line of business applications. Now, the reason I classify them as sort of more line of business enterprisey is if you go down the Forms approach, you end up with an application that looks relatively bland, okay? And it's a little harder to do more creative visual effects on it. Now, it's not to say that it's impossible, but you will have to do custom renderings for each of the platforms you're targeting. And by the time you do that, you're basically back to looking at traditional Xamarin, where you're building the user experience once for each of the platforms, engaging a platform specialist to build each of those, okay? The problem with Forms is it is designed as a rapid application development platform, okay? It's designed so that you can do, form surveys, that type of things very quickly by defining the markup or defining the layout once, and having it produce applications that work across the various platforms. Okay, so talked about the platform as a whole. Let's get into a little bit of the developer technologies. So we're going to talk about application structure, and I want to focus on two parts. First of all is the life cycle of an application. Like most mobile-oriented platforms, we go through a cycle where our application starts in a not running or not started state. User hits the button and launches our application, and we go into a running state. Okay. User doesn't want to use your application anymore, so they go off and do something else. And your application goes back into a suspended state. So imagine on a phone, you go to your start screen, you tap on an icon, your application launches, it comes into the foreground. You use it for a little bit, then you press the start button, then you go back and you select another application to work. So your application's gone into the background. And quite intuitively, you'd imagine that it gets suspended at that point. Now, that used to be the case in Windows Phone. It was very predictable. As soon as you went off into something else, application went in the background, it got suspended, and then sometime in the future, if resources were required, it would get tombstoned and you'd have to deal with it getting rehydrated or reanimated at some point in the future. The Windows platform model is slightly different, okay? Firstly, your application doesn't necessarily get suspended when it's no longer in use, okay? So imagine a windowed environment. You've got two applications there, you're toggling between them. Imagine if your application got suspended every time. Okay, that'd be a really infuriating user experience because there'd be this glitch as you go between the two applications. So it doesn't necessarily suspend your application as soon as it goes into the background. Now, interesting enough, if you actually minimize those applications, generally you do get suspended. Now, this behavior is non-deterministic, so I wouldn't put any reliance on your application always getting suspended as soon as it goes into the background. There are other ways of working out whether you're no longer in focus. So, for example, if you look at the windows, like the actual property on the window, and you look at activation, or you look at, and that's not to be confused with the application level, activation and deactivation. So at a window level, if you look at activation and deactivation, or you look at visibility and not visible, Those have different meaning depending on what you're chasing. So visible, not visible, okay, on Windows Phone, that's pretty deterministic, okay, because it's either in the foreground or it's not, and it kind of maps one-to-one with activated and deactivated on the window. On a desktop environment, it doesn't, okay? Desktop environment, just because your application goes into the background, it could still be visible, right? So the visibility property change won't get raised in that instance. However, the activated change event will get spun up as it goes into the background. Now, where this life cycle is important is when you think of the way your application gets started up, okay? We have an application class, okay, and that effectively becomes the entry point to your application. And you'll notice here that in the diagram, it actually says that going from not running to running, there's an activated event, okay? Now, this kind of doesn't manifest itself as an event that you can subscribe to. The way that you hook into that is you do it by overriding a number of methods in the application class. And the two that are of most interest are onLaunched and onActivated. And there's actually a couple of different permutations of onActivated, depending on whether you're being activated because somebody's clicked on a file that's going to launch your application, or they've clicked on a toast notification that's going to launch your application. So there are different ones of those, and I'll show you a little bit more about that in a second in the demo. The next important thing to note is how you're going to structure your application in terms of navigation. Again, if we look at simplified environments, and this has kind of been led by the iOS and Android world, there is only one kind of navigation. You click on an element, you go to another page. You click on an element, you go to another page, okay? And typically there's some metaphor for going back, okay? So Windows Phone actually had a great job of having a hardware back button that would give you that navigation back along your back stack. The problem with Windows is that now that we're dealing with big displays, all of a sudden we don't just go one page to another page because we're going to end up with very boring windows. So what we typically do is we think, okay, well, how do we subdivide our page and actually make use of sort of almost sub-elements within our page? And quickly you end up with this notion of navigation within a subframe. So you can imagine your mail application, you have a list of your inbox on the left, and as you tab through things, you're actually changing what's displaying on the right-hand side. That's kind of this sort of master-detail relationship. And it gives you this idea of subframes, because imagine the email pops up and you click on an attachment and all of a sudden it opens another page in the right-hand frame. So now you've got the notion of a backstack actually being created in that right-hand pane. Okay, so the user can traverse back into the main message. And then if they hit the back button again, obviously they go back to the inbox. The other thing we can worry about is multiple windows, okay? We're on Windows. Make use of multiple windows. What staggers me is that the number of applications that Microsoft's working on and have released, how many people have installed Threshold 2, so the most recent update for Windows? Okay, if you haven't and you're running Windows, get the latest update. It's really good because there's a lot of performance improvements, there's a whole bunch of new functionality, including the new centralized messaging application. I prefer it on phone than I do on the desktop because it actually centralizes your text messages and Skype messages into one interface. Unfortunately, the limitation, particularly on desktop, is that unlike the desktop client for Skype, you don't get pictures and things like that coming through yet. What frustrates me about this is that it is a single window still. Okay, this is Windows. Hello, make use of multiple windows, right? You know, when I open a message thread with somebody, allow me to open it as a separate window that I can pin to the side and don't move it. Okay, how many people remember Windows Messenger? Like before Facebook took over Messenger, right? You used to be able to open a message thread, pin it to the side of Windows. In fact, you can have 15 of them all open at the same time, all switching between them. Okay, this is Windows. Start thinking about how you can leverage multiple windows. Okay, let's jump in and do a little bit of a demo. Ooh, did anybody see that? So, I don't know whether you saw it, I saw it. My Windows had to log on because it actually decided to go to sleep on me. Nice thing about these new machines, Windows Hello. Think about how you're going to protect your application, because one of the security aspects that you can actually leverage on these new devices is Windows Hello. Okay, so Windows Hello is the sort of consumer name for being able to log on just with taking a picture or using your fingerprint. It's actually the backings around a rebranded Microsoft Passport. And so this allows you to protect data based on who the user is and verify who they are as part of your application. So the same technology that actually sits behind Windows Hello, which is the consumer brand for signing in using your face, actually can be used within your application to secure data within it. Okay, so if you're thinking about encapsulating passwords and things like that, think about actually using Microsoft Passport to protect those credentials. Okay, so let me switch over to here. And you'll notice that we've got the familiar new project dialog. I did remember to tell you that this is a 200 session, so we're going to do file new project. And we're going to create a blank application. You notice there's a couple of other templates, but unlike what we used to have in the phone, where we had different templates for doing things like a panorama style application or a pivot style application, they've done away with those sort of example applications. What I would suggest you do though is if you're interested in doing Windows platform development, go and get the universal platform samples. Like, let me see, have I got it open here? So it's available on GitHub, and it's a list of there's 205 examples in here, and it covers virtually every part of the platform, okay? Whether it be sensors or multiple windows or projection or things like that, there's pretty much a sample for everything. It's also quite good because it gives you some examples of how Microsoft's coding things. Now, I'm the first to say that Microsoft doesn't always, from a sample perspective, doesn't always code things the way I would. There are some nice aspects to the way they code the samples, and then there's some pretty nasty ways that they do it. Like, they don't use MVVM. Okay, well, not very well anyhow. So I wouldn't copy their metaphor for doing MVVM. However, some things like the use of the split view, which is a control we'll talk about in a minute, I do think that those samples are quite good because they give you a baseline from which you can work. Okay, let me go ahead and create the app. Okay, and particularly on this display, you come up with a whole bunch of text that actually doesn't mean very much. And what we're going to do is come over here, and we're actually going to find our main page and at least show you some visuals. Okay, so what we should see here is the designer experience for building out our page. Now, the interesting thing here is that it gives you a mobile version of our page, and we're thinking, okay, well, this is pretty limited. What do I want to do? What happens if I want to do the design for my desktop application? The really nice thing about the way that they've re-architected this design surface is that they haven't hidden this stuff in another tool window. It's actually there at the front of our design surface. So I can actually switch between a phone style interface and a desktop style interface. Okay, so let me select the 23-inch, and we'll just refit that so it all displays on the screen. All right. And over here from my toolbox, I'm going to go ahead and find a text block. And there's a number of ways that you can add that to your interface. In this case, I just double-clicked on it. And you'll see that it's added that to both the document outline, the display there. Let me zoom in on that, okay? And you can see that it's added it to the XAML at the bottom of the screen. If I come over to my properties window, I can again modify some things on there. So let's say hello Ignite. And let's find a couple of alignment properties. Let's center those. And we'll change the font just to bump it up a little bit on the desktop. Okay. And I'll then go ahead and run that. Now, while this is, oh, there we go, it's already done. I was going to make a quick note, the fact that at the moment I'm doing a sort of a develop and debug and run using the debug build configuration. Now, a lot of people switch to release mode and then wonder why it takes 5 minutes to do a release build and deploy. And it's just like, okay, well, something weird's going there. So one thing to be aware of is that the deployment through the store now uses .NET Native, okay? And so part of the problem that we saw with previous iterations, so for example, Windows 8.1, is that they were doing the .NET Native compile in the cloud, or the engine of our applications in the cloud. What we were seeing is that there were then some inconsistencies between the developer experience of running and debugging our application and the application that comes down from the store. So Microsoft actually took heed to that and made sure that there was a good way for developers to test and debug their application in the same way as the application coming down from the store. So by default, when you switch to the release build configuration, it will do a .NET Native compile and it will do an optimization the same way as the store would do. Okay, so just be aware of that. If it takes a while, that's the reason for it. Okay, so we've got Hello Ignite. We're in a window, so we can do things like resize the window. We can also minimize it, et cetera, et cetera. Let me stop that, and what I'm going to do is I'm going to show you the same application, but I'm actually going to target the mobile emulator. Now, I mentioned before the versioning, okay? So if I downloaded the latest tools, so the previous set of tools, or the emulators for those, what I'll see in this window here is I'll actually see mobile emulators targeting the RTM build, so build 10.24.0. If I downloaded the new emulators, I'll actually see double that number of emulators, okay? So I'll actually see the ones targeting the new version of the SDK. I'm going to grab the version that's actually already open here, and I'm going to just deploy that out. Here we go, deploy succeed, and hopefully it'll then go and invoke it. Okay, so we have the same application running on two devices. And notice no code changes. So let me switch back. Okay, so clearly building one application for running on multiple devices, we're going to have some challenges when it comes to user experience. So the first thing to do is to go and get yourself a designer, okay? If you're used to building stuff yourself as a developer, even back on Windows Phone 8.0 or back in Windows Forms, you should have always been working with a designer. I'm a developer and my design capabilities are shocking. The only applications that we produce that look awesome are ones where we've had at least a designer involved up front, okay? So that's the first rule of thumb. Second of all is if you're going to be building for all of these devices, make sure you have a test device or multiple test devices, because as the number of devices that you're supporting increases, so does the number of test devices that you're going to have. Now, the good news is that this is not Android, right? So we don't need like a literal cupboard full of different Android devices, because every time a bug happens on Android, you have to go and buy the device, run your application on it, and there's some weird esoteric bug that you've then got to fix that's specific to that device, or specific to a version of the software that's on that device. It's not that, okay? We're still building for one platform. So the good news there is if you have one phone, you have one desktop, you have one slate, chances are by the time you've tested and debug your application, you're pretty much 98% of the way there. Now, there may be some few glitches as you resize your application for different form factors. Those come with testing through the emulator, okay? Because the emulator does a great job of giving you those in-between states as well. But there's nothing like testing on a real device, particularly as you start to make use of device features, particularly now that we have to support not just multiple device shapes and sizes, but also we have to support voice, stylus, touch, keyboard, mouse, okay? This is a universal platform. It means that pretty much people can interact with your application the way that they want to, okay? And you need to test with all of those, okay? Now, voice is easy actually, because if you choose not to support voice, you just don't do the Cortana integration, or you don't use the voice recognizer, right? So that makes voice easy. But the rest of it, you kind of have to think about how you're going to test and deploy for, okay? So multiple device types, multiple form factors. So, if you're talking about desktop, you still need to develop across slates and tablets and desktop, right? So there's this grouping called device families, okay? So mobile is basically phone and tablets up to a certain size. Desktop is tablets of a small size, tablets of a big size, hybrids, desktop, multi-screen monitors, that type of thing. So that's all desktop. Surface Hub actually falls into its own bucket. That's a team device, okay? So that's a different thing again, okay? There's Xbox and then the Surface Hub. Now, there are SDKs that come out for each of those that give you access to device-specific capabilities or device family-specific capabilities. We'll talk about those in a second. And lastly, orientation, okay? Phone particularly, people will switch between portrait and landscape. Tablet, slates, again, portrait and landscape. It's less likely if you're running on a desktop PC for somebody to actually swivel the display. So you don't really need to worry about that, but you do need to worry about orientation from the perspective of a window. So you can imagine somebody's got a window that's stretched like a landscape orientation. Okay, now they resize it down to a portrait, okay? Because they can, it's Windows. The window's resized, right? So all of a sudden, just because they haven't switched the device from portrait to landscape doesn't mean your application shouldn't respect the fact that they've resized it down to effectively a portrait view or a landscape view. Okay, this brings on to the concept of breakpoints. You can see here on the left-hand side, we've actually got a portrait view. Now, I don't know that there's any telltale indications, but that could be either a phone or a desktop. Now, it is actually a phone because you can see at the top it's got a status bar. Now, that's a mobile status bar. You can tell because I haven't seen it rendered like that on desktop. So that is actually the mobile version of the mail application. It doesn't have to be. It could actually be, just a portrait version of your desktop application. Okay, so imagine you then stretch that out. You get to the middle display where you're seeing the inbox, you're seeing the mail items, but you're only seeing a thin sliver of the menu bar or the split bar. As you stretch it out even further, you can actually see the whole contents of the menu on the left-hand side. Okay, those are what we refer to as breakpoints. When are you going to change the layout from one orientation to another? When are you going to change it from so that you can reveal more content? Okay, Microsoft spent a lot of time iterating the first-party products that they're shipping. So things like the news application, the maps application, the mail application. So I would suggest that you go and have a look at those. Now, there are some arguments that those are a little inconsistent. Yeah, they've spent a lot of time, different groups, iterating them in different ways. Now, they are standardizing those, so what you'll see over time is that they're converging on a central model. They're pretty good right now, and you can use them as a pretty good benchmark for how you could think about the breakpoints for your application. Microsoft likes to talk about the 6 R's, okay, so from a design perspective, and these are ways that you can handle this adaptive or this responsive layout. If you've done responsive development or adaptive layouts for web, it's very similar to those, okay? It's the same concept, and in fact, you can approach it the same way. The first is resize, okay? So this is the easiest one to do. You basically dock everything, and as the user increases or decreases the window size, they're going to just stretch out the various layout elements so they take up more space. This only gets you so far. If you stretch too far, things look really out of proportion, and it doesn't look a particular good use of the space. Next thing to do is reflow. So this is a classic, we've got one column of data. As we stretch and we've got more space, we can actually reflow onto another one, okay? This is one that we actually use very heavily for the work we did with Sportsmate around their sporting applications. Because again, we had to allow for the fact that we were running on different size screens. So whilst it was still an 8.1 application, the way that we handled that was effectively we actually allowed reflow so that as there was more depth to the content, so imagine that they switched from landscape to portrait, as they increased the depth of the content, we actually allowed it to scroll over multiple ones, and we actually allowed it to reflow over multiple columns. Repositioning, this is a very classic one for dealing with orientation change. So as you switch from a landscape orientation to a portrait one, you can just reposition things, okay? And I'll show you in a little bit how you can use state triggers to do something similar to this. Next is to reveal content, okay? So as you stretch out the screen and you've got more space to work with, at a certain point you might decide, okay, well instead of stretching things, I'm actually going to shrink that down again and actually reflow and also reveal more content. Now the thing to watch here is that this can actually, if you don't do this well, it can be a very jarring experience, because imagine the small portrait version there. As I stretch it out, I'm going to get to a point where it's kind of stretched out a little bit, and then I want to start introducing more content. Now, if I introduce more content, they've got to stretch it even further to start seeing that. So what I might want to do is actually reduce the left-hand pane back down again. If you do that straight away, the user's just going to go, what just happened? Okay, so you've got to think about how you apply animation there to actually gracefully slide it there and actually grow the right-hand content. Re-architect is a common one. So this is typical for interfaces that don't lend themselves well to stretching or to growing. And so what we can see here is a sort of a pivot style display that would be typical on the phone versus a sort of a contact style list that would be typical on the desktop. And lastly, replace. Okay, so this is where the UI elements that were used don't make much sense. We've still got the same kind of navigation context, so we're still switching between essentially collections and albums, but rather than using the pivot display, we've actually decided to have a much more sort of a grid line layout for the desktop interface. Okay, one of the things that's kind of hidden from us is this notion of scale factor, because if I pick up my mobile phone, these days it could be running a 1080p display, okay? And I compare it to a desktop monitor, 19-inch desktop monitor that could also be running 1080p. Now, if I build an application for the phone, and I use exactly the same number of pixels on the desktop, it's going to look really magnified, okay? Because I've got like a 6-inch device here, and I've got a 19-inch monitor, okay? So Microsoft's decided that, well, we don't want developers to have to code per pixel, okay? Because that would be really annoying, you know, because if I'd have to change everything for every pixel layout, that's going to be really, really frustrating. And the other thing that comes to play here is the fact that people view these at different distances, okay? So I typically hold my phone about here, a slate or a tablet I hold about here, and for Surface Hub or an Xbox, it's across the room, okay? Now, the Surface Hub is actually an interesting one because there are kind of two fields of view for Surface Hub, because on one hand, you could be up close and personal with it using the pen and actually drawing on it, in which case you don't want things to be massive, but by the same token, you could be across the conference room, in which case you still want things to be visible at that kind of reach. And that actually proposes a lot of design challenges for actually building for that team-style interface. So this notion of scale factor is designed to accommodate both the viewing distance and the pixel density, so the DPI effectively. And so the idea here is that when we're coding our applications, what we do is we code in effective pixels. And the idea here is that a 1-inch display, so basically if I have a square that's 1 inch by 1 inch on the phone, should be about the same as a 1 inch by 1 inch display on the PC, and that's again on the Surface Hub. Those are perceived 1 inch by 1 inch, right? So it's not going to be an actual measurement, okay? But from my eyesight, it should appear the same in all three of those devices. And that's this notion of scale factor. So it happens automatically. You don't need to go and do too much work to support it. There are some cues within Visual Studio to actually let you know what type of scale factor you're actually designing for. So that's just something to be aware of. If you get a design from your designer in Photoshop and you kind of set it as the background within your application so that you can lay out things and position things 100%, and then you run it on a device and it doesn't look anything like what the design was, that's probably because you weren't using the same scale factor that they were building for. Okay, so 1 inch according to your design wasn't 1 inch according to their design. Okay. The last note here, a couple of last notes. Firstly, when you're picking which scale factors to support, and this is particularly for image assets, okay, because if you're going to on a high-resolution display, you probably want to provide, high-resolution assets, and so you typically generate those at different scale factors. So typically, you'd pick 100, 200, and 400 to support for those. Unfortunately, this changed from Windows Phone and Windows 8.1, where they were, I think, 100, 120, and 160, or something along those lines. Anyway, it's nice even numbers to match with what, surprise, surprise, other platforms are doing. The last thing to note there is that the scale factor worked well with the 4-pixel grid. I just want to switch over and actually show you some help documentation that actually talks about that, because it's a useful, very useful read. So this Responsive Design 101, assuming we get that up. Let's try that. Right. So this is the MSDN docs around design for the Universal Windows platform. And so you can see that there's a number of topics on the left-hand side. The one thing I wanted to call your attention to is this 4x4 pixel. Okay, so if you align your designs to the 4-pixel boundary, what you'll see is that as the scaling factor takes effect, you'll see that it adheres to the pixel boundaries and that you don't get unnecessary blurring. If you don't align to the 4-pixel boundary, what you see is this kind of blurring effect, okay? So you can see that the font and even this image over here hasn't actually aligned to the pixel boundary. So you get this blurring in the edge of it. So that's just something to be aware of as you go about designing your application. Okay, let me just skip back here. Okay, so a couple of things. One of the good things is about a lot of the controls that come with the Universal Windows platform is that they support automatic layout. Okay, so things like spacing in lists and the support for touch versus stylus versus versus keyboard and mouse, that's all handled for you. So nearly all of the controls are equipped to handle or to be controlled by touch or by keyboard and mouse. Okay. Things like, there are some controls that actually behave slightly differently. So for example, the pivot control, when it's rendered on mobile, actually just renders as a pivot control, so you can slide between the two. On desktop, it's actually more like a tab interface. So that's just something to be aware of in terms of those controls. There's a couple of new controls, the relative panel, and this is primarily there to support people coming from Android, where that's the prevalent way of actually laying things out. It does give you another design option or another layout option in terms of how you position things. I wouldn't say there's very many layouts that you can't do with a grid that you can now do with the relative panel. It just gives you another option that may be easier to work with in certain cases. The split view is a really nice control. It gives you that ability to have this sort of burger-style menu that pops out, and we'll use that in a second. And one of the really nice additions to Visual States is the support for triggers. And out of the box, they come with an adaptive trigger, which is designed to adjust which visual state is currently running based on the size of the window. You can go and build your own. There is actually a NuGet package that you can reference that actually has a whole bunch of these. So for example, you can have a different visual state based on device families, or based on whether there's an accelerometer, or based on whether there's a camera. So those are all different adaptive different triggers that you can actually use in your application. All right, let's continue with our demo application. And what we're going to do is we're going to take this basic structure and we're going to introduce a couple of things. And so we're going to start off by going and looking at, we're going to go back a little bit and talk about the actual navigator, the launching mechanism for our application. So remember I talked about there being these overrides. So there's on launching and on navigated, on activated. And you can see here in the code that this is our override for the on launched method. So this is included out of the box, and so this is kind of required in terms of actually getting your application up and running. This is one of those things that looks okay to start with, but as soon as you get into building out your application, you realize that you need to recode it, or you need to change it and customize it to your application. So do be aware of it. The bulk of it is that it looks to see if there's an existing frame in your application. So that's this line here. And so you can see here that rather than there being a root frame to your application, there is now a root frame to the current window. Okay? Again, we're in Windows, right? So there could be multiple windows. It looks to see if there's an existing frame. If there's not one, it goes down there and creates a frame, and then you'll see further down here that it actually calls a navigation on that to go to the main page. The last thing, and probably one of the most important things that developers often get wrong, is that they then call activated, okay? If you don't activate your window, it never comes into the foreground, it never displays. Now you might be going, okay, but hang on, let's just back up a little bit. This on-launch method, isn't that supposed to happen once when the application launches? No, it's not as deterministic as that. If you have your application running and you double-click on, say, a live tile, the launch method actually gets re-invoked, okay? And so that's why it's important to actually detect to see whether there's an existing frame rather than just go ahead and randomly create another one. So if I run this up again, let me actually do that and just step through there. You'll notice that this gets hit, and it's pretty much the first thing that gets executed. Okay, so, and then we can step through. If you ever wonder what those numbers are in the top left-hand corner, the frame rate counters, that's what's enabling those. If you don't like them there, you want to take screenshots of your application, that's how you disable them, get rid of that line. Okay, as we step through here, no surprises, it goes ahead and creates a root frame. So if I look at the current content there, it's null, so that's null, so it's going to go ahead and create it. Okay, you can imagine that the rest of the code still works. Let me just stop that. And what I'm going to do is go into manifest file, and we're going to configure our application to register for a custom file type. And we'll give that a name, we'll say custom, and we'll come down here and we'll say, give it a content type and a file extension type. And you might be wondering why I'm doing this. I'm doing this because it's the simplest way to show you what happens if you don't support an on-activated method. So, go into here, no surprise, we've launched our application, so on launch gets invoked, right? Now let me come to our file system, and I have got I've got a file of that type. Okay, it's actually just a text file, and what it's going to do is it's going to prompt for my existing application. Let me just go and remove that one. All right, so notice that it brought it to the foreground, okay, but it didn't hit the breakpoint again, okay. Okay, so that's fine, but what happens if my application's not running, okay? So I've closed it. Now, you might be wondering, okay, but Visual Studio is not running, so how am I going to debug it? Well, let's just show what happens if I click on it with it not running anyhow. It launches my application, but never gets to that front page, okay? The secret here is it hasn't gone into the onLaunched event, okay? Let me come back here, and what we'll do is we'll go up and we'll actually override the onFileActivated method, and I'm going to set a breakpoint here. Now, the trick here is that if I run this, which we'll do, and it's going to hit my onLaunched, okay? I go to hit here, and if I double click on there, surprise, surprise, it gets onFileActivated, right? So it hits that, okay? If I now close it and do that again, okay, so you can imagine it's still hitting the onFileActivated, but it's still not doing the right thing, okay? Now, I can't actually debug what's going on there because I have to start with my application closed, so which means Visual Studio is not running. There is a trick to this though. If you go into project properties, there's a debug option that actually says, do not launch, but debug my code when it starts. So checking that option, hit run, my debugger's kind of attached to it, but the application's not running. Now when I actually go to here and actually double click on that, it'll actually hit my breakpoint on the onFileActivated, so you can actually diagnose what's going wrong. And I can clearly see, well, hey, it's not creating the root frame at all, right? Because I can scroll down here, and if I hover over this, it's going to say, oh, well, that still equals null. I don't have a frame, okay? But I'm not creating a frame because on the onLaunched, it never gets invoked, okay? So let me just fix that for us. So I'll close that, private void launch. Okay, so I'm actually reusing the same logic. I'm just going to call it a different method, and I'm going to call that method from both the onLaunched and the onFileActivated. Launch. And if I just compile like that, it's going to complain because I have to comment a couple of things out of here. Because I'm not actually, just for demo purposes, I'm not passing the arguments through. Okay, so let's run this. Okay, remembering it's going to run, but not have it actually run. And now when I go into here, when I double click on there, it's going to hit my breakpoint. I run that, and our application will come up, and it gets to that first screen. Okay, job done. So the important thing there is, if you're going to take advantage of some of these things, like launching a file type, you do need to override some of those onActivated things. I would highly recommend that you, by default, you override. There is an onActivated. I would suggest that you at least override that and point it to the same code that you run through as part of your launching process to make sure it all invokes properly. Okay, so let me continue on, and let's just do some basic navigation stuff. So let me go to my main page and the code there. So we'll go to the designer, and I'm just going to add a button underneath here. Okay, and I'll add a click event to that. And of course, there's a couple of things that's firstly going to happen here. Firstly, I don't have a second page to navigate, so I'm going to have to create that in a minute. The other thing here is that the designer is complaining, or it will complain when I look at the visuals, that I don't have, these are going to render on top of each other. Okay, so let me just put these into a stack panel. And I'll put that stack panel right in the center as well. Okay, let's see what that looks like. Okay, they should be somewhere in the middle there. Okay, let's actually do this properly and switch over to Blend. Okay, so the nice thing about Blend, it still reuses the same code file, so it'll still pick up the same solution. As I make changes here, it's actually going to render, and surprise, surprise, it actually has the text block there and the button. Okay, so let's switch back to Visual Studio. We're actually going to create that second page now. So go add new item, blank page. Don't be confused by clicking on the XAML view, okay? That will give you just a .xaml file. It will not give you the XAML file and the code behind file. The reason why that's there is so that, for example, if you want a device family specific XAML, so for example, say you want a completely different XAML page for your mobile version versus your desktop, you can do that by creating a separate XAML view, okay? And you need to give it an appropriately named name. Okay, so let's create second page. And let's just do something simple like put a text block in right in the middle again. Just so that we know it's there. Right, and let's go back to our main page, and we'll select on our button, and we'll go through definition there. And we're still going to do a simple navigation. So each page actually has a reference to the frame that's currently hosted in. Now, the Windows Phone model and the Windows Desktop model had kind of different ways of accessing the navigation context. This is obviously, since we're putting one application, it's all accessed from the page by the frame attribute. And so from there, we can basically go navigate, and we need to provide it the type of page that we're going to navigate to. Now, if you wanted to pass parameters and arguments and things like that, you can do as part of that navigation operation. In this case, we're simply going to navigate to it. And you're going, why didn't that run? Why didn't that run? Well, it did run. Well, Visual Studio ran. Our application didn't run because we checked that box, remember? So, okay, so let me just get rid of that breakpoint. So our application's there. As we navigate, it goes to the second page. Now, interesting thing here, let me show you the same thing, but let's show it on the mobile device, because it'll become pretty evident what the problem is on this device. Okay, so it comes up, we navigate to the second page, and then I go, okay, well, I want to go back to the main page. Hey, where did my application go? Okay, there's no default support for the back button. Default support for the back button is, well, we'll go back to the application that was prior to your application. So we'll hide your application, we'll go back to whatever's before it. And since that's the only application I've been accessing, it goes back to the start screen. Our application is still there, so if I tap and hold on there, our application is still there. And no surprise, it's still on the same page. So it hasn't done any form of back operation, okay? The reason for this is because if the platform decided that it was going to go back, like the old Windows Phone model, when you hit on the back button, the default operation was to go back to the previous page. The platform did that, and you wanted to host a subframe and actually do your own navigation there, then hitting the back button might not do the right thing. And similarly, if you have multiple, like say you had a tab display, the back button might be specific to your application. You might want to set them back through there. Now, I wouldn't recommend that, but certain applications would want to do that. There's a number of different permutations that developers have come up with that would want to reorientate the way the back operation works. Because in theory, the back operation should take the user back to the previous user experience, okay? So whatever they were on previously. It may or may not be a different page. It may be a different visual state. So imagine the mail application. When you reduce the size of it, you've got a list of items. You tap on an item, it goes to the details of the full message. Pressing the back button, actually, this is one page, right? So pressing the back button should actually take you back to the list, not back to the previous page. It should take, but that's all visual states within the same page because we built it as one application. Okay, so the way that we can handle that in this particular case is that we need to provide a device platform-specific implementation for the phone, because if you look at the back button, there is a consistent back experience across all of the platforms. So if you look at desktop, tablet, and the phone, they all have a notion of a back button that you can make use of. So on the phone, it's a hardware back button, or it's a virtual hardware button. So the 640 and the 640 XL have this virtual button that can actually be dismissed, but it is still a hardware back button that is actually there on the display. When you're dealing with a device running in tablet mode, what you'll see down the bottom tray is that you can actually put a back button in the bottom tray. If you run it on a desktop build, the back button that you can surface is actually in the top navigation bar. Okay, so we'll show you that in a second. So let's come back to my second page. Let me just view the code. And we're going to add some specific behavior for the back button on the phone. Now, because the phone is slightly different, it has a hardware back button. So we're going to, in order to access that, we're going to add a reference to the Windows mobile extensions for UWP. I mentioned before that there's a couple of different platform versions now, so or SDK versions. I'm going to pick the most recent one. You can actually target on either of them, depending on which version you want to provide minimum support for. I'm going to click OK on that, and you'll see that that's appearing in our reference list. And what we can then do is navigate to, we can do windows.phone. Okay, so immediately we've got a phone namespace. Okay, that wasn't there before. Okay, that's been added because we've got a reference to the SDK. Now, the thing to bear in mind is that at development time, you've got a reference to that SDK. When you deploy on the device, those namespaces are only, or those classes are only there when you run it on that specific device family. Okay, so what you need to do is you actually need to test for their existence before you call them. Okay. So the actual API I want is input.hardwareBackbuttons, right? So that's the class name that I want. Now, there's actually a method called API. Let me find out what it's actually called. Let me just grab this code. It's going to be quicker. So I'm going to cheat a little bit in the essence of time. And what we have here is we have API information.isTypePresent, and we're basically looking for that particular class name. I don't particularly like the fact that we've got string literals in our code. There are a couple of alternatives that we can use in terms of making use of the new name of keyword, but essentially they're going to provide a string literal into this isTypePresent. And if that type does exist, then we're going to attach an event handler to the back pressed. Okay. The other thing we're going to do is we're actually going to provide support down here for the virtual hardware back button that appears on desktop. Okay, so we can actually tell it to, when it doesn't have a hardware back button, we can actually say, okay, we want you to display a view back button. So this is the back button that would appear if it's in tablet mode. It's in the tray down the bottom. If it's in desktop mode, then it's in the top tray of the application. And again, we're going to attach to the back requested. Now, unfortunately, that back requested has a different event handler. So what we end up with is 2 event handler methods. And I've got some simplified code that basically does the same operation for either of them. So basically, it looks to see if we can go back, and then it navigates back. So let me run this. I'll run it on the phone first so you can see the support's there. Now, this code that I've just added in there, I added it specifically to the second page, but you can imagine adding that to a base page and then having all of your pages inherit from that, so you get that built-in support. So let me navigate to the second page. I navigate back, and I get back to the first page, which is exactly what we wanted. Let me run the same thing on desktop, and I'll actually show you that the desktop version of that back button. Okay, so we navigate forward, and you'll see that we've got this new back button appearing in the top left-hand corner. Okay, so that's the desktop version of it. Now, my problem with that back button is particularly on a large display when you've got a lot going on the screen. The user noticing that back button is kind of remote. Okay, so don't just rely on that as the only metaphor for the user to traverse back or to another place within your application, because pretty soon you're going to get a complaint coming through going, I'm stuck on this page, where do I go? There is a back button there. Users are not particularly intuitive about looking for things like that until they're familiar with it. Okay, so it is a little hidden. It is there. You can make use of it. I would recommend that you at least make use of it, but I would provide another metaphor elsewhere in your application for users to get back to those, at least a home or a landing page. Okay, so the next thing we're going to do is we're going to switch over to Blend, and we're going to make use of split view. Okay, so I'm going to quickly come down here. I'm going to say, okay, well, this stack panel, so the contents that I have on this main page, I'm actually going to chuck that within my split view. And so we'll grab that, and that's going to be my contents of the split view. Now, the split view is one of these really nice controls that has essentially two areas. It has a split view.pane, and so this is the pane that you'd imagine would come out in a burger menu style. So when you click on the burger, the menu comes out. That's the pane part of the split view, okay? The body of the split view, so the main content property of the split view, is basically everything else on the page. Okay, so you'll see here that we've dumped the stack panel within the content of the split view, and virtually no change to the layout of the page. What we're then going to do is going to do split view.pane, and this basically allows me to design what's going to be in that sort of the menu that pops out when I expand the split view. And actually, I'm going to seal this button and actually going to throw that in there, just so we've got an element in there. So with split view, I can come over here and let's actually see what that looks when it's open. You can actually see that it's laid, it's shifted out the split view there. I know it's pretty small, but you can actually see that little gray area is the split view popping out. So I can hide that like that. Now, clearly, we need a metaphor for the user to open and show the split view, because currently there's nothing on the screen that they can click on to open that. There's two ways that we're going to do this. Firstly, we're going to have a hamburger-style menu. Okay, so we're going to have a burger thing there that they're going to click on, and we're going to essentially use a toggle button for that. The second thing we're going to do is, as they stretch out the screen, we're actually going to make use of that screen space to actually automatically open that split view pane. Okay, so we're going to actually show them that it's already there. So two things. Let's firstly add in the button to do that. So let me come back to my grid. I'll go up here, and I'm going to create a second row there. The first row is going to be an auto, because it's going to have the button in it. And I'm going to cheat somewhat and come down here and grab my button. This is one of those things that I stole out of the samples, because I was wondering, okay, well, how do I get the same look and feel of the hamburger thing? So I went to the samples and basically borrowed their burger menu. So that's in the first row. Let me just change the split view to be in the second row. And of course, let's get rid of the right thing there. Okay, and the other thing is you'll notice that there's now a bit of a warning that this style doesn't exist. So let me grab this style from here. And I'll come up to my page, and I'll just drop that in here. And so what we should see at the top of the screen there, let me just see if I can zoom in a little bit on that. Okay, so there's our burger there. Right, the next thing we're going to do is we're going to control what happens to our split view based on that burger menu. So let me just come over here, toggle button, and we'll go through on that button click. And all we're going to do is we're going to do split view dot, let's make sure my split view actually has a name. As soon as it likes to actually find my split view, so that I can code against it. Is pane opened equals not split view dot is pane open. Okay, so let me just run that up. And so one of the nice things you'll see with the blend in 2015 is that the debugger actually attaches, so you can step through your code the same way as you do in Visual Studio. Okay, so it's hit my same breakpoint. Okay, so now what we see is as we tap on that, it's going to automatically hide and show the split view. Now you notice that the split view actually has an inherent behavior where if I tap outside of it, it automatically hides away. If I'm actually in a larger screen, so let me just display it like that, I probably don't want it to auto-dismiss. Okay, so at the moment the split view, its display mode is set to overlay, which basically means that it comes out over the top of all of the content. What I might want to do is actually, when I'm in a larger screen like that, I might want to change it so that it actually pushes the rest of the content over and actually stays there until I actively dismiss it. The other thing we're going to do, as I mentioned before, we're going to have a visual state change that actually will automatically show the split view when there's enough screen. So let me just stop this in Blend, and we're going to come over here and to our state window, and let me come back to our main page instead of app.dot. And we're going to say, okay, let's create a couple of visual states. So these are going to be my layout states. Give that a name, and we're going to do a wide version, and we're going to do a narrow version. And so you'll see there's a new little icon here, which it says Edit Adaptive Trigger. Okay, let's click on that. And so what we're doing here is we're adding triggers that will invoke that particular visual state. So if you had a number of state triggers, it'll actually step through each of those triggers and validate that they're all true, okay, before it switches to that visual state. At the moment, my project's only referencing an adaptive trigger. Okay, so we'll go ahead and add one of those. And what we're going to do is we're going to say that when the minimum window width, and that says height and width on there, is 640, we're going to transition to this particular state. Okay, so we should see that our wide, let me just confirm that that's on there. Okay, so we've got an adaptive trigger on the wide one, and we don't need to add one to the narrow one. What we're going to do though is we do need to actually make some changes to our layout based on those visual states. So with our wide selected, we're going to come down to our split view, and we're going to say, I want this to be in inline mode, and I want to say the is panel is open. So let's just save that and run that. Okay, so let's just hide that, and hopefully as we go out, he says, all right, let's just make sure that not narrow one, we specifically set this to narrow, to overlay, and sorry. Yep, that's cool, let's just run that again. Now, the last time I ran this, I don't know whether you noticed, but it came up with a prompt saying restore NuGet packages. For the longest time, I've been used to doing Control-Shift-S as I switch between Blend and Visual Studio. Unfortunately, what that does, it also saves the solution file, which means that it kind of it forces Visual Studio to go, I need to do a build, but actually I need to do a rebuild. When you do a rebuild in Visual Studio or Blend, it will go and validate that you've got all of the necessary packages for the universal platform, which is why you're seeing that restore NuGet packages. So if you can avoid doing that, the better. Let me see whether my demo is actually going to work. And as I resize this down, voila, it disappears. Let's see if it actually works going the other way. Okay, my split view is popping open and closed. So I can still manually invoke it, but notice that if I tap anywhere out here, it's not automatically dismissing because it's in that inline mode, so it's actually pushed over the rest of the content. Whereas if I reduce it down, when I've got this open, if I tap outside of it, because it's in that overlay mode, it's disappearing. Okay. So that's an introduction to both the split view and the adaptive triggers. Let me switch back to... Okay, so the next thing is that there are a number of things that are distinctively Windows, okay? Some of these fall into the category of updates, so things that we've had in previous versions of the platforms, or phone or desktop, that have just had a bit of an update in Windows 10. So things like live tiles. Now, my personal belief of live tiles is that they now play second fiddle to notifications, okay? Live tiles used to be very prevalent in Windows 8 because you used to land on the start screen, okay? They're less significant now in Windows 10 because people hit on the start key, they type the name of the program they want to open, they launch the program, and they don't spend that much time in the start screen or the start menu. If they're running in tablet mode, they'll spend more time because obviously when they press the start key, it goes back into that sort of start screen. And you'll start to, you do have that experience where you'll want to pin things the same as you would on the phone. Quite often you'll pin things just for convenience on the phone so that you've got ease of access to things. And so I think live tiles on the tablet display when you're in tablet mode and on the phone is still fairly prevalent. And if your application is geared for those scenarios, then definitely think about using live tiles. If you're talking about desktop, live tiles definitely play second fiddle in notifications. Notifications are the more significant of them because we can now have fully interactive notifications, which essentially means that you can bubble up a notification from your application rather than the user tapping it and launching your application or going into a part of your application. They can actually interact it directly within the Action Center or the Notification Center. So you can have things like a text prompt there, so you can automatically reply to a message. You can have a multi-select or a selection box, okay? So you can have a drop-down box there that people can the user can select an item from. We've had customers that are looking at using this for providing sort of feedback based on the application, so they'll bubble up a notification that actually asks the user to evaluate certain features of the application. And rather than them having to go into the application and then complete out a feedback form, they can literally interact directly with the notification. We have a company that's looking at using this to send out surveys. Okay, so they're actually going to use that. And the surveys are probably like 8 or 10 questions. And what they're going to do, rather than packaging these all as one notification, which would be quite lengthy, and there's kind of a limitation on the size there, they're actually going to structure it as a single notification. And when the user fills in that form, or that particular question, and hits next, background service gets invoked that then prompts the next question, okay? So that you can step through like a multiple sets of questions, and you can have next and previous and all sorts of things like that, because you can feature up command buttons that allow the user to do that. All the time your application is not actually running, a background task that belongs to your application is getting invoked from those interactive notifications. Now, I mentioned that there's some new templates for both live tiles and notifications. These are around adaptive or responsive layouts for the fact that we're working across a wide range of devices, okay? In the past, if you wanted to support both Windows and Windows Phone, you had to provide a huge number of variants on the different tiles that you wanted to support. The idea there is that these have been simplified, and this is a continuing process where Microsoft will continue to invest in that formatting to make it easier for developers to work with. Oh, sorry, there's one last thing that actually didn't make it onto that slide. One of the things that has got an uplift in Universal Windows apps is the support for background tasks, or particularly operations that you need longer execution in the background. So one of those is extended execution. So imagine your application goes into the background, but you still need to do something. So for example, you need to save a file, or you actually need to do things like tracking location, okay? This is something where you need to effectively request the user to say, hey, my application needs longer to run. Do you agree to this? And so there is a mechanism using extended execution to actually support that. Things that are new to Windows 10, we've got support for Cortana. Now, the support for Cortana is actually not new, okay? What's new here is the ability from the interaction with Cortana to actually invoke a background task. Previously on Windows Phone and Windows Desktop, you were able to do a sort of a pseudo link in with what was Cortana, which is actually voice command, okay? So you could do a voice command definition file, and that's essentially what Cortana uses as to understand or to listen for particular commands that your application understands or can service. So that's how you do the Cortana integration. The big new thing to Windows 10 is the fact that that can launch your application in the foreground, or again, it can launch a background task. And so the idea there, your background task can provide data back into that Cortana interface, again, eliminating the need for the user to go into your application to actually do something. Okay. So again, it's about providing an alternative way to get access to the functionality of your application without necessarily launching it. Of course, we're in a windowed environment, so new to Windows 10 is the fact that we can do multiple windows. We can do this thing called Continuum. Okay, now this is one of those things that again gets multiple branding associated with it, or multiple marketing things associated with it. In this context, what I'm referring to is the ability to have your application running on a phone. When you plug it into a dock, all of a sudden that phone application comes across into essentially a desktop monitor, mouse, keyboard. It's the same application, but it's running in this Continuum mode. Okay, again, it's not too dissimilar to having multiple windows, and it's not too dissimilar to actually dealing with projection, okay? Now, I had a great little thing that I was going to show you. I was going to show you the projection sample from the SDK. Unfortunately, the problem with that is that, of course, it's going to take over the fact that I've got slides up there. So it actually shifts my display from being in duplicate mode to extended mode, and all of a sudden you get this weird kind of behavior going on. So it's actually a really bad demo to give in front of an audience. But needless to say, as part of the samples there is both a multiple window and a projection sample. So if you're interested in that, they kind of have very similar aspects to them, because if you think about projection, it's just another window into your application. The difference is that it's essentially in this sort of remote control mode, as opposed to multiple windows where the user can be interacting with them directly. Okay. One of the last things I'll refer to is data binding in MVVM. There is a bit of a change in the syntax that you can now use for data binding. So if anybody's ever worked with any of the XAML platforms, you'll be familiar with this kind of binding syntax where you're saying bind to this particular property on the current data context, okay? And the data context typically flows down through a page or a user control from the top element all the way down to its children. You've got things like one-time or one-way binding or two-way binding in the case of input elements. That hasn't changed too much in this new version, but we're changing to use the word binding to this new word xbind. Okay? The difference here is that this one, unlike the standard binding interface, this one actually does not use reflection. Okay? It actually generates code at compile time that means you've got a much faster interface layer between your underlying code and what's going on the screen. Okay? The start screen, or the start menu, if you tap on there, notice how it comes up pretty much instantaneously, okay? And if you look at the mail client, pretty much comes up straight away. Those are both actually using this, okay? So they've worked very, very closely with the team and to understand where the performance implications are of using data binding and why first-party applications just couldn't be written in the existing binding syntax because it was just too slow. And this is something that we've been screaming out for years, okay? Binding is so slow, okay? If you ever worked with the map, it's incredibly slow to do data binding. There's been about 3 or 4 different incarnations of the map control, primarily because the binding interface is so slow. Phone, they had it, then they didn't have it. Desktop, they had it, and then they didn't have it, primarily because they could never get binding to work quickly enough. Okay. Binding leads on to MVVM. If you haven't experienced MVVM, it's basically the separation of concerns between what's going on the visuals from what's going in your data layer. I'd highly recommend investigating it further if you're going down the data binding approach. If you're doing anything with XAML, you kind of need to be basing your architecture on MVVM. There's a number of really good libraries, all of which now support UWP. Lastly, toolkits and components. There's a bunch of those out there. NuGet packages, the first thing that happens when you create a UWP application is it goes and grabs a whole ton of stuff from NuGet. If you don't believe me, look at the references and you'll go, there's only one reference there. Open up NuGet Package Manager, look at that particular reference, and you'll see that there's about 40 different things that it depends on, okay? Those are how they deploy the UWP platform, okay? The advantage there is if you don't like or you run into an issue with the current one and you think, I'm sure there's an actual issue here, go and get the latest version of that particular dependency from NuGet, and you might find that it's actually involved and Microsoft's actually fixed that particular problem. Okay? Again, Microsoft's got into this mode where they can actually iterate this stuff much more frequently. Visual states, there's a whole bunch of triggers out there. Notification extensions, when you get onto dealing with tiles and push notifications, don't write XML. I caught one of my developers handcrafting XML the other day. There's a NuGet package for this. Don't ever write it by hand unless you really, really need to. The NuGet package is really good. It's been there for eons. It's been there to support phone and desktop already. It's been updated to the Windows platform, so go and use that instead. And lastly, third-party components. Third-party components, surprisingly, have actually been really quick to get onto the UWP platform. There's really good controls from Component 1, Syncfusion, and Telerik. And if you're doing anything with data, SQLite's also supported on UWP. All right, I'm only about 2 minutes over time. So what we might do, if people have questions, I'm going to hang around here. I'll be out in the speaker lounge in the exhibition hall. Make sure that you complete your evaluation. A note 5 is for high. That's what you should be marking it. If you put your evaluation in, you go into the chance to win a daily prize. Highly recommend that you do that. And it's important for us to get feedback on how you thought the session went as well. Thank you very much for attending. See you guys in the exhibition hall.